Okay, let's get started. Welcome back and good morning, everybody. I'm Alex Casalboni. I'm a technical evangelist from AWS. I'm based in Italy, but I travel a lot and I'm here in Kyiv every now and then. So come and talk to me if you're curious. This session is about serverless only. So I've seen some show hands during the previous session that was about breaking the monolith and how to use ECS and EC2 and Lambda. So this one is only about Lambda, so it's a good continuation. And we are going to take it one level up, and we're going to talk about multi-region or global kind of applications. So just to get a feeling of the audience, I've seen some hands before, but how many of you are actually using serverless in test, prod, dev, whatever environment? Cool. Not too many. So we'll need a little introduction here, but don't worry, I'll be quick. So 2 words about me. I'm a software engineer, a web developer, data scientist, however you want to put it. I have a strange background. I studied sound and music engineering, if that's weird enough to you. I organize some serverless events around the world called serverless days. There are a few around Europe. If you want to organize one here, I will be happy to support you with that. And I've been an AWS customer for almost 5 years in my previous startup called Cloud Academy. So if you want to hear about startup stories, or if you want to hear about, let's just say I know how it feels to be on the other side, so ask me anything, I'm here the whole day. So the topic of today is serverless, and that is how Werner Vogels, our CTO, introduced serverless back then. I think this is from at least a couple of years ago, so it's been around for a while, this serverless thing. We announced AWS Lambda in 2014, it went GA in 2015, so it's been out there for more than 4 years. And there are customers using it in production, there are customers doing great stuff, even multi-region, global kind of application, which is the topic of today. Just 2 words about what serverless is about, because maybe Massimo didn't talk too much about it in the previous session. So it's not, again, about not using servers. We like servers, you like servers probably. The thing is, most developers do not want to deal with servers every day. They don't want to have that concept as part of their daily workflow. So they want to talk about applications and code and databases and data, business logic in general. So that's why everybody wants to just write business logic. So what serverless allows us to do is to kind of abstract away all the infrastructure, networking, VPC, configuration, and basically you only focus on business logic. There are a few tips and tricks here and there to be aware of, and today we are not going too much into that, like cost optimization and security and configuration management. Not today. If you're curious about that, I can link you, connect you with a few more people or talks or YouTube videos. So the goal of today is to dive a bit deeper into this concept of global applications or multi-region. How many of you have already built a multi-region app in your career? A few, great. So how many of you know what's a region, an AWS region? Everybody, oh man. Sorry, I needed to ask it. So for the others, or for the shy ones, or for the sleepy ones, an AWS region is not a physical data center. Okay, it's a logical set of what we call availability zones, and inside those availability zones there are 1, 2, or more data centers, physical data centers. Okay, so people build multi-region, multi-availability zone applications for various reasons, and we'll see why in a second. Welcome. You're not shy. Cool. So some fundamentals. The whole idea of using more than one region is because when you put components in parallel, what happens to availability? Does it go up or does it go down? Any guess? Not down, sorry, it goes up. So if you have the same component and you have 2 or 3 or 4 of them in parallel, and you can choose which one to use at a given time, your availability, your ability to stay up and running is better, right? So there is actually some math behind this. So I don't want to dive deeper into the math. But the idea is that if we have component X and you can use 2 of them in parallel, the availability goes up based on that formula. So you basically do 100 minus 100 minus the availability of a component squared, because you have two of them, right? If we add X and Y in series, their overall availability would be smaller than their independent availability. That's also math. But today we want to focus on using stuff in parallel, because that's how you can be more resilient and more available. But in numbers, in real human, understandable numbers, what does availability look like? Well, if your component is 99% available in a year, okay, in 36 days of uptime, that means you could be down for 3 days, 3 days and a half, even more than that. Okay, and that's 99% availability. Okay, we want to do better than that. You don't want to have 3 days of downtime every year. So if you add 2 more nines, that's why we count availability with the number of nines. We don't want to go below nines. So if we have 4 nines, so 99.99%, you get less than an hour downtime per year, which is a bit better. If you get 5 nines, or is that 6 nines, you get 31 seconds maximum downtime per year. Okay, that's the kind of availability that global, huge applications that are very revenue sensitive. If you are down for a minute, that's probably already $1 million. Okay, those kind of applications where you want to minimize downtime at this level. You can add more. I would say if you add more, you can almost consider it 100% availability, because below 10 seconds, nobody will notice anyway, let's say. So the idea here is that redundancy allows us to be more available or more resilient to failures, because things will fail. If there is one thing we are sure about, is that things will fail, and you should design and plan for those failures. One way to do it is to have more things in parallel of whatever you're building, and that will allow you to be more resilient. And that's why we have more than one region as well. Okay, we have different reasons for creating more AWS regions. One is to improve latency if you have customers locally, geographically based in a specific country or region. Another one is for the largest customers to actually build multi-region applications, so that they can have the resiliency of 1, 2, 3, 4, 5. There are more than 20 around the world. So I would say above 5 or 6 doesn't make too much sense. And we'll talk about data replication. We'll talk about different techniques to actually go and use more than one region. So right now we have 21 AWS regions around the world with more than 66 availability zones. The best thing about serverless, in my personal opinion, is that you don't really have to think about availability zones too much. But let's discuss the fundamentals together. So that's the idea. You have a region. Within a region, you have more than one availability zone. And on a region perspective, you can already do multi-data center architectural designs. Okay, if you have more than one availability zone, you are already doing distributing risk across risk-independent geographical areas, because each and every availability zone is localized in a geographical area with different, like, how do you say that? Let's say different risks. Sorry, I'm not a native English speaker. So you can already be pretty resilient in one region using multiple data centers, but we can do better. So the idea is that you want to have your elastic load balancer or application load balancer, and you would be able to distribute the load of your application across more than one data center or availability zone. We can do better. We can extend it a bit further and have independent regions and have some sort of balancing using Route 53 at a DNS level, for example. That's an option. This is already better, of course. What happens with serverless components is that they already kind of span multiple availability zones. You don't have to configure it, okay? When you deploy your Lambda functions and you give it your 20 lines of Java, Python, Node.js, whatever language you're using, you don't have to configure VPC, you don't have to configure which availability zone your code will be running. You can, but you don't have to. If you have specific requirements about reading data from a RDS database or from a Redis cluster, okay, you can deploy your functions to a VPC, and then you can choose an availability zone. But most serverless applications actually don't. If you're using DynamoDB, for example, there is no need to to deploy your function into a VPC. So most serverless applications, that's completely transparent. And we take care of deploying your applications to multiple availability zones. So there are a lot of people, when they look and compare costs, each computing layer has a different cost and a different set of operations and maintenance and configuration that needs to happen. And if you look at just the hourly cost, okay, Lambda is a bit more expensive than EC2, but because all this stuff is done for you. So consider the human cost, consider the configuration cost, the security, the operating system security patches that you don't have to take care of. So that's included in that additional cost. And that's the idea. You pay for value, you don't pay for compute hour. You do pay for 100 millisecond compute intervals. So if your functions run for 600 milliseconds, you pay for 600 milliseconds. If that's all you do in a month, that's all you pay in a month. There is no minimum, hourly, daily, monthly, and so on. The consequence of us managing the infrastructure, again, is high availability within the scope of a region. Okay, today we bring it further and we want to use more than one region. But why? What's the point? We have talked about the two main reasons, if you think about it. One is availability and resiliency. The other one is, any guess? GDPR could be could be a good one. A third one could be speed. So you might have specific latency requirements for a specific customer or a specific audience, and you don't want all your customers to go through internet all the way to, I don't know, Oregon or Virginia, if your customers are in Australia. So maybe you want to help them with a local region in Sydney, and you replicate the data there, and you do all sort of magic to make sure they don't have to travel across the world just to get some API response. So improving latency might be a very good reason for that. I don't know if you're familiar with the latency in milliseconds around the world. It goes all the way from 150 all the way to 3 or even 300 or even more milliseconds. So if you have a server down there, because most of your customers there, the random customer in Alaska or in Italy or in London will have a hard time. So the idea is that the more regions you have, the easier and the faster and the closest your data and your service will be to your final users. So that's a very good reason too. But the real one, I would say the really big one, is usually improving availability and resiliency. Because what happens is that, imagine you have two customers, two clients, whatever, in San Francisco and in New York, so West Coast and East Coast, and you have two services deployed in two different regions, like Oregon and Virginia. Okay, what happens is that if something goes down for any reason in the West Coast region, well, we can simply just reroute all the requests to the other one. If you have 3, you are even more. If you have 4, you are even more resilient. So some prerequisites. What does the CAP theorem say? So since we are already accepting the idea of network partition, because we have multiple regions and multiple availability zones and everything, we have to choose between consistency and availability. And distributed systems usually choose availability because we want to be up and running all the time. What do we sacrifice? We sacrifice data consistency. And it doesn't mean data is not consistent. It means we can accept, we can tolerate that data will eventually converge to a stable status within milliseconds or seconds. We can accept that in most distributed systems. And there are techniques to go around it and deal with it. But that's the main idea. If you want to embrace multi-region, global, highly available, highly resilient applications, you have to accept this idea of eventual consistency. And we'll talk about data in a second. If you want to dive deeper into these concepts and go really technical and deep, do you know that guy, James Hamilton? That's the guy that basically built the AWS Global Network back in the day. And he now speaks at re:Invent and global conferences around the world. So check out that video. It goes deep for like a couple of hours on exactly this stuff. I'm not an infrastructure guy, but he really is. So check it out. So what about data? How can we make sure that, if we have different regions, we probably have to have 2 options. Either we have part of the data in one region and part of the data in another region, like partitioning at the regional level, or we just replicate everything. And we can serve any user from any region just based on latency, maybe. If our goal is improving latency. Maybe we have a user that travels a lot. I travel a lot. So when I open my app in New York, I want to fetch data from the closest region. If I'm in, I don't know, Sydney for a week, I don't want to go all the way to Sydney just because my data is in New York. I want to fetch it from the local closest server. So there are a couple of options here. Today I'll talk about one of the most popular one that we have built on top of Amazon DynamoDB, which is our NoSQL database, and it is called DynamoDB Global Tables. So what's the idea? You have your NoSQL DynamoDB table in, I don't know, Dublin, and at some point you say, hey, can you just replicate all the data also to Frankfurt and Virginia? Why not? Actually, there is a little caveat that you have to configure this behavior before adding data to your table. So the table must be empty, but that's for now. Hopefully, we'll go and fix that in the near future. But the advantage of global tables is every write you do on any region will be automatically replicated to all the others. And if we have two regions, it's not crazy to do it yourself. You can use the DynamoDB streams, and actually global tables is built on top of DynamoDB streams. So every time there is an update, you just go and write to another region. But if we have 3, 4, or 5, synchronizing all of them is a bit tricky. So customers ask us, can you build that for us? Sure. And now we have global tables. So the advantage is that you do not have to rewrite the application. Your application running in Virginia will read and write from the database in Virginia. Your application running in Frankfurt or Dublin will read and write from the database in Frankfurt or Dublin. So there is no application change. You just deploy the same stuff to 2 different regions. And I'm going to show you just that in a few seconds. If you are a relational person, it's actually, that's a stupid argument. If your application requires relational data, better. There is the same option for Amazon Aurora, which is our MySQL and Postgre compatible database, cloud native. Basically, we rebuilt everything under the hood, but you can use it as if it was MySQL or PostgreSQL. So the point of Aurora Global Database, I think that's only compatible with MySQL right now, is that you have the same functionality. So you read and write from your local region, and Aurora will distribute it to all the other regions. So pretty much the same. I don't know why they have different names. It should be the same name. Global database. There are other data, types of data that you may want to replicate around different regions. So one of the most popular is data on Amazon S3. Who has data on Amazon S3? Everybody has data on S3. So I call S3 the grandparent of every AWS service because you kind of have to use it at some point. So there is a very fancy and easy way to set up multi-region replication on S3. So if you have configuration data, images, assets, whatever you're storing on S3, you want it to be available on every region, you can just configure it with a few clicks. And that's pretty neat, in my opinion. Cool. Okay, what about routing? How do we make sure that customers or clients will actually go and use the most convenient or the region that is up and running? There are 100 different ways to do that. So let's see some of them. So the service we're going to see and to use is Route 53. That's how you manage your DNS, your name system. So there is one option. If your main point is to optimize latency, you can use Route 53 latency-based routing. Okay, that's basically done for you. You don't have to configure much. You just say, hey, there are 2 regions here, just based on the client actually requesting right now, pointing to the closest region. Not closest, but to the fastest region right now. So if you have 2 different regions, wherever they are, the request will go through the fastest region. It doesn't really need to be the closest, it just needs to be the fastest. So it's latency based, not geographically based latency. There is a geo-based latency. This is slightly different. I think that's more based on the actual user location. And Similarly, if you have a region in Virginia here, the user is in New York, you want to route it there. User in Seattle or San Francisco, it will go to Oregon in the West Coast. There is even a way to just do a weighted kind of round robin, just iterate over all the regions option. So you will go to Oregon or Virginia or Dublin in a weighted way, and you can apply a weight too. And Route 33 can even handle failover. So if a region actually goes down, or if your service in that region appears to be down right now using health checks, it can fail over to another region that is up. So, okay, and then at some point, Oregon goes down, never happens. Oregon goes down, and we'll keep using Virginia for a while until Oregon comes back up. Okay, there are a million ways why your service might be down. Maybe your developer pushed a bug in the application, or maybe there is a transit error. There are a million ways to do that, but you want to have health checks every few seconds to make sure the region is up and running. Having a failover makes sense for that. There is a new option since a few months. There is this service called AWS Global Accelerator. The Global Accelerator, okay, if you think about serverless application, it's a bit weird because it works only with load balancers, so not with the API gateway or with the typical services that you use in the serverless space. But since a few months, you can also use Lambda with application load balancers. So imagine you have an application that's using ECS or EC2, and you have the traditional application, and at some point you want to say like / my new feature, this path, I want to implement it with serverless, with Lambda. Okay, you can just map that path to a Lambda function. So you can have this kind of strangely hybrid architectures using instances and containers and Lambda functions at the same time in the same architecture. So that's a nice way to extend already existing apps. And the Global Accelerator for serverless apps using an application load balancer allows you to basically accelerate applications. But let me show you what happens. The idea is that at the network layer, if you have your clients wanting to request resources to your AWS region, they usually go through a lot of hops, network hops. Okay, and in each hop there is random latency, middle to middle, all sort of risks, and blah blah blah. And on the way back, the same, might be even a different path. So very unstable, very unpredictable. What the accelerator does for you is it brings it down, it shrinks it to one network hop. To the Amazon global network. So you get in there using the local ISP, and from there you are inside our network. So it's predictable, we control it, it's high throughput and low latency. So that's a better way to accelerate your app. If you're already familiar with the concept of CDN, Content Delivery Network, you maybe are already doing something like this using CloudFront, which is our CDN. So this is, let's say, a better way to do it without the caching layer in between, just to accelerate network under the hood of your serverless applications or server-full applications. It's demo time. Let me show you something that was built like this, and let me guide you through the steps. So it is a typical serverless application. We have an API tier, a Lambda computing tier, and a database tier. We have Route 53 in front of it to do latency-based routing, and we have the global table synchronizing data across these two regions. Okay, let's go step by step and see how we actually create and configure this app, and then I'm going to show you the actual live one. It's all on GitHub, by the way, so you can check it out later. So first of all, we need to create the data, right? Without data, we don't really go anywhere. If your application doesn't have data, I tell you it's much easier. Tell me about those applications, please. So first of all, we create a DynamoDB table. We give it a name, and it's the typical Dynamo setup. What you need to do is you need to enable DynamoDB streams, and you need to make sure that the table is empty. So you have this beautiful wording up there. Enable streams, make sure it's empty. It doesn't work otherwise for now. So once you've done that, you enable the streams, and you can add multiple regions to this global table. It's called global table because you can think of it as one table. The data will be the same in every region. You can I think there are now up to 10 regions that you can add to it, but again, I think above 5 or 6 doesn't make sense anymore. But we'll look at the numbers to see how availability increase based on the number of regions that you have in your multi-region application. So once you've done that, you find all your regions listed there in your global table, and you can actually go and look at the data in all the configured regions. Data is fine. Nothing to configure, nothing to change in our application logic if you already have a serverless app right now. Lambda layer, it's business logic, it's compute. There is no Docker file, there is no crazy configuration. There might be if you want to do proper infrastructure as code, and I encourage you to do that, but it's usually, 20 lines of YAML purely focused on your business logic and configuration, environment variables, and so on. So that's my business logic. It's nothing crazy. I'm instantiating some clients. This is my main or my handler, call it however you want. I'm loading some stuff from the body. I'm reading the value and the key. So basically, it's the stupidest application you can ever build. It's a key value store for, you give it a key and a value, it will store it. If you only give the key and get it, you get the value. Stupidest ever, but I'll show it to you in a nice UI later. So the idea is that this is the, what is this? This is the put item version. So this is the set business logic, and there is another function doing the get business logic, nothing more crazy than this. So we extract the key and the value from the body, we put item into the DynamoDB global table. We also write the region. Okay, so in the database, we are also writing which region was the data written originally, just to keep track around all the other tables. This as an exercise. You don't really have to do it. I think it's fun to see what happens. And then just we return 200, and we return the data back as well. That's just an example to show you that in 2 different regions, Ireland and Frankfurt, I see exactly the same data. I have the key, I have the value, same, exactly the same. And I also have the original region where that item was written from. So I can read it and write it from any other region, but we are keeping track of that. Great. Code, business logic is done. We need another layer for API. And if you want to have, latency-based routing, maybe using a public host name, you probably want to set up some custom domain magic on API Gateway. So you need to do 2 things on API Gateway. This is my API. Make sure it's a regional endpoint, because you want to deploy 2 regional endpoints, or 1 regional endpoint for every region. That's the idea. So when you create an API Gateway API, you specify regional. The other option is edge optimized. There is a third option, which is private for VPC kind of endpoints. But for this kind of multi-region application, you want to have a regional endpoint. What's the difference? If we have an edge optimized endpoint, basically there is a CDN in front of it. So we don't want to have a CDN in front of every regional endpoint, otherwise the whole thing doesn't make sense anymore. The second thing you need to do is to specify a custom domain. So here I have this beautiful domain that I bought a couple of years ago, global fast website, and I've mapped that domain to each and every one of my regional API Gateway endpoints. So that's it. You do it in every region and you're done. The third step is to configure Route 53. How do we do that? Well, I wanted to do latency-based routing. So in my hosted zone on Route 53, I've configured 3 CNAME records, each one mapping one of the regions. In my app, I have 3 regions. And each region is configured with a latency routing policy. That's it. Once you do that, Route 53 will manage their latency checks for you. Optionally, you can configure health checks as well. I think for this specific one, I didn't configure it, but you can. Cool. Let me show you what it looks like. I have a beautiful map subdomain just to show you what the map looks like. And here we go. So it's tiny. Okay. So this is my application. It's a map.global.fast.website. And you can fork it on GitHub. You can find the front end and the back end into different repositories just to separate things. It will ask me about my current position, and I already granted permission, so I'm correctly geolocalized in Kyiv. And then I have some regions. You can see all of them in the map. The black and white ones are regions I'm not using. There are a few ones, I don't know if you can see, that are colored, like Germany, Ireland. There is another one here in Oregon. Okay, so if I click there, I can actually go and use that endpoint. What can I do? Well, I can say, I don't know, test key. Here I specify a key, and here I specify a value, and I can write that value into the Oregon region. Okay, I've written that. I got a cold start. It took about a second and 300 milliseconds. If I write again, it will take 300 milliseconds, because from here I'm hitting Oregon. It takes 300 milliseconds to get there. If I now go and read from Frankfurt, which is the closest region from us, I think, and I read that key, I find my test value, and I see that it was written in Oregon, so it works. It was synchronized right now. We also got a cold start, about 800 milliseconds. If we read again, I expect it to be, roughly about 70 milliseconds. So that's pretty close to us. The network is not too bad. Imagine what happens. Okay, let's test value Germany and write a new value into Germany. And then I go to Dublin and I read the same key, and it's already test value Germany written in Frankfurt. I'm reading from Dublin. Okay, here I'm using the regional endpoints directly because I wanted to show you, the synchronization works, and you can still use the regional endpoints. Imagine you have a backend application in Frankfurt. It doesn't make sense to use the latency-based routing. You may just want to go and write and use the local endpoint. It does make sense if you want to be highly resilient. So what happens is that I can now show you what the latency-based routing looks like, and it's kind of magic, so you don't see much. But if I go and invoke /test value, that's my global endpoint that I will give to my clients. And there I expect to see, woo, beautiful. Test key, let's see what happens. Oh, test key, not test value. So test value doesn't exist, but test key exists. And let me see, here we are reading, it was written in Frankfurt, and I am reading from Frankfurt. So if I go here and write it in Dublin, and I invoke this again, right? It was written in Dublin, and I'm reading from Frankfurt. So the data is synced in really a few milliseconds, and I can just give this global endpoint to my customers, and they will not even need to care about which region they are reading from. So you can find all this on GitHub, check it out. It's built using the serverless framework. I built it last year, but really any technique works. I want to tell you a little bit about SLAs and what all these numbers mean as far as availability, and at least let's call it expected availability. Because so who knows what's an SLA? I guess a lot of people. So I've met so many developers that confuse SLA with actual availability. Okay, it's not. Availability is something. SLA is, let's say, a financial and legal protection for you in case our availability goes below that value. Okay, so let's call it minimum expected availability for today. So we have some SLAs for Lambda, for API Gateway, for Dynamo, and for Route 53. So we can take those values and do some computation, some math, just to see what happens if we go multi-region. So what those numbers mean in a year is roughly 4 hours of downtime, maximum downtime, because that's the minimum expected availability, right? Roughly. It's pretty crazy to me that it's 100% for Route 53. So you can expect that to never be down. Makes sense. And Dynamo is actually 5 minutes downtime per year. It didn't actually happen, It's a maximum worst case scenario. We do worst case as engineers. So looking at these numbers, let's put them in the chart. So if we replace the service with a number, that's what it looks like, right? So we have 99.95 for API Gateway and Lambda and 5 nines for Dynamo. If we look at the individual region, we kind of achieve 99.899. As I mentioned at the very beginning, if you put multiple services in series, their overall availability will be lower than the individual availability because they depend on each other. But if we look at the system overall, and we are basically taking that number and using the formula that I showed you at the beginning, we are doing much better than the individual region and then the individual service. So we reach, it's not 4 nines, but it's very close to 4 nines. And we started from individual services having 3 nines and a half. So that's a pretty good improvement just with 2 regions. What happens if we have more regions? So let's do some more math. Sorry about the math today, but this is important. So with 1 region, we were there 9 hours of downtime with that setup, maximum in a year. With 2 regions, we reach about 1 hour of downtime. So it's a 10 times improvement already, just adding 1 region. If we add 1 more, we go down to 5 minutes. This is the same availability expected, minimum expected availability of Dynamo, but for the overall system. If we add more, we get to, is it 6 nines, 30 seconds of downtime in a year. If we add more, you basically get 100% uptime, 0 downtime. So that's roughly the numbers, you know, kind of back of the napkin math that I did 2 days ago while having breakfast. But this is real, okay? So that's minimum expected availability for your multi-region applications using Dynamo, API Gateway, and Lambda. Do your own math, add in your you know, Redis and Postgres and blah, blah, blah. This is how you do the math. The formula at the beginning is on the slide, but basically you just remove the square of the individual availability from 100. Nothing crazy, really. And if you look at the availability on a chart, it goes up pretty quickly, okay? From 1 region to 2 regions, you improve 10x. And then you keep improving 10x, basically, at each additional region. You don't see much difference up there. If I zoom in, it will be a 10x improvement. As far as costs, because that has an impact on your design as well, this is some math that I did last year. Basically, the cost for DynamoDB kind of depends on which building model you choose. Now you have 2 different options. One is provision capacity, meaning you say, I need X reads per second and Y writes per second. That's your provision capacity. And this is the computation. So based on the ratio between reads and writes, and based on the number of regions, based on the color, so your cost will go down if you have more reads than writes, basically. It will, I think this is logarithmic scale, I can't remember, but the idea is that it goes to 0, which means the cost is the same. Actually, it goes to 1. It goes to 1, meaning the cost is the same if we have many more reads than writes. Why? Because you have a multi-region architecture. Every write needs to be written in all the other regions. So if you have a lot of writes, the cost it will be n times larger. But if you have many more reads than writes, basically the cost is the same at very large scale. Based on the number of regions, that kind of depends how large the system needs to be to converge to 1. If you're actually using the on-demand capacity that we announced a few months ago for Dynamo, all of this does not make sense anymore. Why? Because you're just paying for the actual queries. So if your system is doing nothing for a week, you have no provision capacity, you have no hourly fixed cost, you know auto-scaling to do yourself. So this chart doesn't make sense anymore, but I expect it to be at large scale very similar. And There is an article that a colleague of mine wrote, Adrian Hornsby. It's a technical evangelist in my team, so he does a lot of resiliency and chaos engineering and availability topics. So if you want to dive deeper into these topics, go and read his blog as well. And I think that's all I had for you today. Thank you very much for coming. Do we have time for a question? How are you on timing? 10 minutes? We have time for questions, guys. So please go ahead.
Hello. So, like DynamoDB has this real-time replication between regions. How about Aurora? Does it have the same option?
So it's called Aurora Global Database instead of Global Tables. It just has a different name. I haven't played with it too much, but it's the same functionality. So it requires the same level of configuration, which is basically 0. I think the limitations about your table should be empty or you need to enable streams. Okay, those are different, but the high-level idea is exactly the same. I think I have some numbers on the slide. Let me go and find it. There were some numbers that I don't have in my mind. Sorry. A lot of slides. One more. Here we go. So it officially can recover in less than a minute based on regional outages. You have a 1 second recovery point objective and less than a minute recovery time objective. So I don't know if that makes sense to you.
So this recovering, as I know, it means that one Aurora cluster in one region works as read-write cluster, and another one works as read replica. Is it correct, or it works?
So actually, it's a multi-master, multi-region setup. So it doesn't mean the other regions are just read replicas. The idea is to have a multi-master, multi-region setup.
Okay,
better.
Thanks.
Yeah. So you can have up to, I think, 12 read replicas within a region. So if we have a lot of reads, you can scale that with a single region. But if you want to write data into multiple regions and synchronize the writes, that's the option. So this is global database. Cool. Another question? We have one question back there.
Hello.
Hi.
Maybe you can say which tool you're using for automated deploys this multi-regional serverless.
Very good one. So I've been using for this specific project the serverless framework because there were a couple of good plugins to handle custom domains for API gateway and even the records for Route 53. So I wanted to do everything with one framework back then. It was a year and a few months ago. But if you want to do everything with CloudFormation, there are some things that are not supported yet. But if you're using AWS SAM, for example, that would be basically the same type of solution. I think with SAM, you probably end up writing a few more lines of YAML. The serverless framework still have a few plugins that simplify your life when it comes to integrating with stuff that CloudFormation doesn't support yet, or that supports, but it's a bit verbose. So here, if you check out the repo, that is here. So you can find github.com/Alex Casalboni, and then it's probably one of the first ones, serverless multi-region client demo. That's the client. If you scroll down, and this is just a React application, if you scroll down, there is another project from another Alex, not me, but we did it together, built using the serverless framework. Actually, this is Alex Debris from Serverless Inc., the serverless framework guys. So you can find both backend and frontend. One more question? One here? Can we have the mic here? Oh, sorry, one more.
Hi, thanks for the talk. Quick question. What happens with DynamoDB streaming events? So let's say I wrote I put a record in one region. So will other regions receive a notification for this event?
So you're talking about DynamoDB streams?
DynamoDB streams and other compatible with DynamoDB global tables.
So I think global tables will set up a stream itself. That's a good question. I don't know if you can have your own stream as well. That's a good question. I need to double check it. My expectation would be that you can also set up your own custom DynamoDB stream and do your own custom logic. So if you need to react on a specific update and write somewhere back or sync another data source, you can do that. But come back with me and we'll double check together. We had another question here. And third. Wait for the mic, please. So it's recorded as well.
What is the typical latency of replication between in the global tables?
So I don't think it's actually stored in the database itself, but I've seen it in the matter of not below 10 milliseconds. I think it's in the matter of tens of milliseconds. I don't know if we have an official metric about that. Let me actually go and see if there is something that I can show you in the database itself. Oh, this is not, yeah. Anyway, I can show you some data, but I think it's in the order of 5 to 20 milliseconds from what I've seen. Actually, in the record itself, you will find your own attributes, like key and whatever attributes you have, and DynamoDB Global Tables adds a few more meta attributes about the replication itself, so you can actually look at the data, when it was written and when it was replicated in the two tables. So you can find out yourself. I think we have time for one more question. Otherwise, you're free. Enjoy the break,
Yeah,
and I'll see you later. Oh, we have a question.
Yes. Hi.
Don't move.
Okay, during the demo, I noticed that the first request to read was like a little longer than all the consequent. So what is the reason for that? Is it because global database table is doing some on-demand propagation, or it was just waiting for it to synchronize?
So you mean that the read request was slower than the write request?
I mean that the first read request was longer than the second.
That's true, and I briefly mentioned it. The idea is that when it's been a while, could be hours, that you have not invoked your serverless functions, you find what we call a cold start. Okay, a cold start means there's nothing running, we need to bootstrap a new runtime, put your code in it, and then run it. Okay, that is, depending on the region, depending on everything, up to hundreds of milliseconds. It could be 200 or 300 milliseconds, and we call that a cold start. So let me show you that if I go and read it in Dublin, now it took 300 milliseconds, but that includes latency, network latency. If I call it again, it's 175. So probably that first call was a cold start. I'm not too sure. It's probably just DNS and SSL and network, unstable network. But sometimes it might take 400. Okay, but that's a cold start, and it happens every few minutes, hours, depending on how we reshuffle resources under the hood. But that's not due to DynamoDB global tables at all. Even if your code is doing nothing and just returning a static string, you will see these cold starts. So we are constantly improving and working on improving that. If you asked me a couple of years ago, it was probably twice as long. Based on the runtime for Python and Go and Node, that's pretty short. So there are actually good articles about different cold starts based on the runtime or different metrics. But that's not global tables. Okay, cool. Thank you, everybody. If you have more questions, I'll be here or out there or around all day. Thank you.